Welcome to the webinar Effective and Reliable Fire Protection through Integrated Design and Process FMEAs at Minimax. Consistency and linkage. My name is Franziska Kramaike and I'm part of the Peak Avenue marketing team. We are pleased to welcome you today to one of our webinars within the Quality and Engineering Circle. I would like to point out that we have recorded this presentation in advance to avoid technical problems due to high registration numbers. But our speakers, Douglas and Sven, are both present at this webinar and will be available for your questions at the end. You can ask your questions via the chat function. I will collect them and ask them to our speakers at the end in the Q&A sessions. You can find the chat function in your webinar dashboard. We will make this webinar available to you along with all other webinar recordings over the next week. I think now we are ready. Douglas and Sven, you can start with the presentation.
Okay, thank you very much, Franziska. I'd like to start. Hello, ladies and gentlemen. We welcome you to the presentation of Minimax Viking regarding the structure of the FMEA in our company. First, we would like to introduce ourselves and our company. Then we will show you the structure of our FMEA. To my person, my name is Sven Föhre, employed at Minimax Viking since 2008 in the area of development and since 2016, mainly responsible for the execution of design FMEA and system FMEA in the Minimax Viking R&D.
Yes, hello everyone. My name is Douglas Stuth, and I'd like to welcome you as well, and also would like to introduce myself briefly. I came to Minimax around 2 years ago as a working student and started in the quality management department. And after a short time, the need for process FMEAs became apparent. So I offered my help in that matter because I became a little bit familiar with the FMEA method during a bachelor thesis for another company. So when I built up the process FMEA concept for Minimax in very close cooperation with Sven, and of course this took a few months, and since mid-2022 I've been carrying out the process FMEAs at Minimax. And in addition to FMEAs, I deal with welding related topics at our company, but this is not our focus for today. And now I would like to hand back to Sven so we can start with our presentation.
Okay, just an introduction of our company. Minimax Viking Group is a global fire protection company with more than 10,000 employees. Approximately 200 employees are responsible for development worldwide. The group has particularly strong presence in Europe and North America. Development is carried out in North America, Middle East, Australia, and Europe. In the field of fire protection, all technologies for firefighting fire are offered, such as water extinguishing systems, gas extinguishing systems, fire prevention systems, or fire alarm systems. Tailor-made fire protection solutions are developed for fire risk with special requirements. The Minimax Viking Group consists of various companies that operate worldwide. Functional risk assessment is currently carried out at the development sites in Bad Oldesloe, DFMEA, System FMEA, Process FMEA, as well as in Hastings, USA. The main production site in Bad Oldesloe produces sprinklers and nozzles, valves, other mechanical components for water and gas-based systems, sprinkler pipe prefabrication, fire detectors for industrial applications, fire alarm and extinguishing control panels, switch cabinet constructions, manufactured and developed. The Minimax Viking Group covers the following fire protection technologies: control systems, fire detection and suppression control panels, detection, standard fire detection, univario industrial fire detectors, Helios aspirating smoke detectors, water-based suppression, sprinkler, water deluge or water mist, gas-based extinguishing, oxygenate gas, carbon dioxide, halocarbon fire extinguishing, and software systems, Clunic Gateway, Design Manager, or Smart Analytics. The Minimax Viking system can be found in a wide range of applications. You will find it in industrial plants, warehouses, cold storages, logistics centers, data center, hotels, power plants, and so on. The FMEA starts at the Minimax research and development in 2004. There was an introduction of FMEA via SKIO software in the area of electronics, fire alarm, and control panels. With the introduction, the FMEA was to be carried out only on products. Due to a lack of processes and personnel, the FMEA was not pursued further. 2016, due to normative requirements and customer requirements, the FMEA was re-rolled in the development area via one person as a moderator using the SKIO software. 2018, we introduced Plato 1. 2020, we integrate the FMEA in the PDP process. 2022, start of the PFMEA in the production area of Minimax technology. 2023, changeover to premium maintenance contract for relief of Minimax IT, and introduction of new models for the PFMEA. From the FMEA perspective, a design or system FMEA is started within R&D at the beginning of product development. I, as the moderator of the DFMEA, informed Douglas, the moderator of the process FMEA, about the design and system FMEA for the kickoff. The start of the process FMEA is fluid. Within the failure analysis in the design FMEA, relevant topics for the process FMEA can already be noticed. Recommend measures for process moderator. The official starting point of the PFMEA is the completion of the failure analysis within the design FMEA. The PFMEA for the manufacturing process is performed by moderator for process and quality management. In addition, process FMEAs are planned for assemble systems at the customer. For example, installation, service, maintenance, and others. The responsibility for the FMEA is located at the plant engineering office, distributed in Germany. However, we currently lack personnel here. Position is advertised. For the creation of an FMEA, Minimax Viking requires various delivery objects to create a complete FMEA. Since development in the past was mainly product and design related, the FMEA now also considers and documents all interfaces and the architecture. The requirements are created by the stakeholders and integrated in the structure tree of the FMEA as the top level. Since the requirements are not clearly stated in most cases, development works through them in consultation with the stakeholder and then creates the functions and errors for the main product. The deliverables are checked for the completeness in a kickoff and may need to be reworked. All persons involved in the core team as well as in the extended team of the FMEA are involved in the kickoff. In the kickoff schedule, the team existing documents for the FMEA are defined. Afterwards, the requirements of the stakeholders are discussed with the responsible person and transferred to the Plato software as the first level. After the stakeholder requirements have been recorded, we perform the individual 7 steps of the FMEA based on the AIG handbook and one additional step, the interface analysis. Now, I'd like to hand over to my colleague, Douglas.
Yes, thank you. Now we will take a look at our process FMEA structure and procedure, starting on this slide right here. And like Sven already mentioned, the actual start of the process FMEA is fluid because some important things that came up in the design FMEA might already be placed in the process FMEA. But however, on this slide, we will concentrate on the official start of the process FMEA, usually including the industrial engineer and the developer. And we start our process FMEA typically by creating a flow chart, as seen on this slide. And we want to improve our process visualization by adding pictures to the process steps, which you can see a few examples on the right side. So here are various pictures possible, depending on which FMEA you are doing. For example, if you have FMEA for a comparable product to existing products at Minimax, we can use the pictures of the comparison products. But if you are doing a completely new development, of course, we don't have any comparison pictures available. So then we can use CAD drawn pictures, as you can see on the lower right corner. And now if we look at our process structure, you can see on the left side of the slide in bright orange indicated our main steps. And the blue symbols underneath the main steps are the respective sub-steps. And we are starting on the slide with the incoming goods inspection because this is in a serious process. In terms of time, of course, the first thing you start with, you receive goods that you want to manufacture. However, in our process FMEA, the start of the analysis from the incoming goods is started later and also finished last. You can see that indicated from the numbers above the bright orange symbols. And the delayed start is mainly due to the fact that we've experienced in the analysis of the pre-assembly or assembly, some important points might come up, or process or product specifications that definitely need to be checked in the incoming good inspection. And this gives us a chance to place those items into the process FMEA system element for the incoming goods before we even start the analysis of that. We think this is a bit more helpful for us in our structure. And yeah, after the incoming goods inspection, you see the pre-assembly, and here we start with our analysis after the flowchart is created. And from here on, we continue with our process FMEA according to the FMEA handbook through the assembly, the product inspection, and ending in the wrapping and storage. So this brings us to our next slide. This slide is supposed to give you an overview over our process FMEA structure. So on the left, you see each step of our process FMEA. In the middle, you see the apply tools from Prado, which we use for each step. And on the right side, you can see the persons we typically involve in our process FMEA steps. So as you can see, we are using various of tools from Prado, for example, Flow, of course, I mentioned, the control plan, the net builder, the process configurator, traces, finder, foundations, and different FMEA sheets for design, system, and process FMEA. And the core team, as you can see, consists usually of the industrial engineer and the developer. We have found in our experience that a smaller core team is better in use of human resources at our company, and is also way better for me to schedule process FMEA meetings. We are more flexible like that. And in addition, it has been found that there's rarely a question in a meeting which the industrial engineer or the developer can answer. So it's a pretty rare state. But in order to involve the other project members, the information collected in an FMEA is shared on the project page on the internet, and also quality management and other experts are involved and informed as required if there sometimes is a question that can't be answered. And you also might have noticed in the applied tools section where some tools are marked with red stars. Those are our interfaces between the design system FMEA and the process FMEA. And in the next slides, we will look at an example project of ours, and we'll go into those interfaces in more detail. And the project you can see here is pretty up to date, actually, because right at this moment we are in the failure analysis within the process FMEA, and this valve is used as an extinguishing agent container in fire extinguishing systems. So when activated, the valve opens and the extinguishing gas can flow to the extinguishing areas. And the reason why we did an FMEA for this product is that we want to take over the production from a supplier. So in the future, this valve will be manufactured in Bad Oldesloe from us. And for this product, then Sven carried out a design FMEA on which our PFMEA is based. And now we will take a look at the project structure from the valve. But this is actually our basic structure. It doesn't differ a lot from other projects. So we start on the top with our stakeholder requirements, which are requirements that are placed on a product system from different departments. For example, the customer, from approvals, from quality management, and from manufacturing as well. And we've also found if requirements at this point are not set clearly, when our developers have a problem to write specifications to that requirements. And underneath the stakeholder requirements, you can see the general product requirements. This system element includes our intercompany standards. For example, quality goals from our company, such as compliance with laws, standards and guidelines, or personal protection. And the next one under this is the product itself. In this case, of course, the quick release valve. And this system element includes all the technical functions of the product to be developed. And below the product system element, we have the product components. And going further down in the tree, we will come to system elements which are marked with a gear symbol. This is where our process FMEA starts. And the process FMEA top level contains our intercompany standards for processes, similar to the requirements for a product in general. And underneath that are our main steps, which we have seen on the flowchart in bright orange symbols, and they contain all the information with all the sub-steps. And as you can see here, we are working in the Plado tool and structure tree, design and process FMEA both in the same folder. And this allows us to better implement our interfaces, such as full design and process failure nets, but we will get to that in detail later. So talking about interfaces on the next slide, we will start with the first one. Like mentioned, we are using traces, and on this slide we can see the application of traces in the view of the design FMEA. So if it's already apparent in the design FMEA that the point should definitely be considered in the process FMEA, Sven ensures that that the point is dealt with in the process FMEA through an action to me. So these actions can be, for example, inspection points for incoming goods inspections, like core diameter, critical bore diameters, test points for finished products, like leak tests, or critical points in the process to make sure that the component A or B is installed correctly. I then get a message via email. I have an action to take care of, and then I will look at the data and will place the content accordingly into the process FMEA. At an early stage of the project, often as a placeholder. So on the next slide, we can see the traces from the view of the process FMEA. So once the action content is appropriately included in process FMEA by me, I will create a link to the design FMEA so that the information is clear from both perspectives, regardless if you just want to read the design or the process FMEA. So, and this brings us to our next interface. Those are failure nets. And yeah, here is an example of a single failure net. And it becomes clear that a failure mode from the product can have a root cause in the process during manufacturing or in the design itself. So, and it is important if you want to do this yourself, just want to mention that, if you want to link over different levels in the net builder using the depot or a function like this, don't link functions, only link failures, because if you do otherwise, the architect will do weird things, makes crazy connections of functions through your structure tree, and will clone system elements. So just keep in mind, if you want to build full failure nets over different levels, just connect failures in the net builder. And now we can go to our last interface that we will look at today. And on this slide, you can see on the left side an extract from the process configurator tool. And on the right side, you can see an extract from the PFMEA PFC-based form sheet within the failure analysis for the valve. So, like I mentioned, as soon as the flow chart is finished, and before we start with the failure analysis, we go into the process configurator with the industrial engineer and with the developer. And here we link the process steps with the respective product specifications, which they have an influence on. So in the pre-assembly, as shown here for the valve, you can see indicated by the red star, we have 37 interfaces where we could negatively affect the product specification with a production step. And the linking of the process steps and the respective product specification leads us to the view that we see an extract from on the right side. So the advantage of this is we can now see in the failure analysis with one view the product as a process specification and also the product specifications which we have an influence on. And we have found that this is very helpful in getting creative and think about potential failure modes. Because also, like you can imagine, an FMEA takes a little bit of time and can be, depending on the human resources, carried out over multiple appointments and over a long period of time. So usually, like I do it, is we have 2 or 3 hour appointments, hopefully once a week, but maybe we all know it, there are conflicts. So you might come in a situation that you've been out of the project for like 2-3 weeks, maybe 4 weeks. And if you want to then continue your failure analysis, we found that it's very useful to see process specification and product specification on the same view. And I also want to make a small hint about this interface as well. I've recently learned that this particular view is only possible within Plato if you use the new form sheet. And this is called PFMEA PFC based. And now we are slowly coming to the end of our presentation, but we would like to mention some future ideas and desirable software improvements. And we stated those on, exactly this slide, starting with our future ideas. So as Sven mentioned in the beginning, of our presentation, we would like to do process FMEAs for assembly systems at the customer, but we need one more colleague to do that. And yeah, but the position is advertised. And also our next idea is we would like to perform FMEAs, consider customer machines, which include our fire protection systems. And also we want to improve the process of our design and process FMEA as well. For example, via more precise role descriptions in an FMEA with associated tasks. As well as process description for the company. And coming next, we want to train our developers and industrial engineers so they are able to perform parts of an FMEA independently and without a moderator. And to the last idea on the slide is the introduction of special features. But as of right now, or 2 weeks ago maybe, we already started to implement this one. So currently we are starting to mark product specifications that have to be checked in the incoming goods department. So through the marking, it makes them easily accessible for me in the process configurator. And when we can easier get the data and look at this in our control plan for the incoming good inspection. But here are still missing some clear description for this process. And this brings us to our next topic, the optimization ideas for the Pleiades software. So first off, we would like to have more translation options. Maybe you have noticed 2 slides ago, the failure net is what it was shown in German, because there's no easy way inside the tool to quickly translate it from German to English. And we miss those translation options, for example, for the net builder or for the structure tree. Also a display function for failures and measures which have already been used in the project. There would be the display function would be nice for that. And also pop-up information if we link in the net builder over different levels using the depot, then a small pop-up would also be very helpful. And the last point on here is more specific to the process FMEA, because I have found that the graphical structure of the flowchart is, in my opinion, way more user-friendly, and it would be desirable, similar to the process configurator, to be able to record process step specifications in the flow as well, and also to be able to draw over different levels in the structure tree on one flow page. I know I can do all this, like adding process specifications to the process steps, and also build my whole structure tree with one view using the process configurator. But I honestly have to say, me as a moderator, I work with the software daily. Yes, I got used to the process configurator and I can work with that, but if we look at an industrial engineer, for example, who will use this tool, I don't know, maybe once a month or every couple of weeks, then the graphical structure of the flow chart would way more better for him to just add the specifications and draw over different levels. So yeah, that would be very helpful, I think. So now, with that said, we are coming to the end of our presentation, and we hope that you were able to get a very good impression on how Sven and I perform FMEAs in our company. And we at Minimax, I'd like to say, we deliver reliable and effective fire protection systems, and we are convinced that performing FMEAs makes a significant contribution to that. So now all that's left to say is we want to thank you very much for your attention and are happy to receive your questions now.
Yes, thank you very much for your presentation. We have now a few minutes left for questions and can start with the Q&A session. As a reminder, you can ask your questions via the chat function.